Hi all, I'm sorry I can't be with you today, but instead I've made this video to help explain an important concept called boiling point elevation. We learned about freezing point depression when we made ice cream and the mango sorbet. If you add salt or sugar to water and freeze it, you notice that if you add more salt or more sugar, it freezes at a lower temperature. Well, the same thing in opposite form happens when you boil it. So instead of lowering the boiling point, it actually raises the boiling point. And you might not have known this, but we did this when we made our fudge. We end up boiling our solution at 235 degrees Fahrenheit, which is above the boiling point of water, which is 212 degrees Fahrenheit or 100 degrees Celsius. And you might say, but Miss Backus, I don't remember having water in our fudge. Well, we had half and half, but if you remember from our first unit, that's mostly water, as many of our foods are. So actually we were boiling water, and we had water and sugar to make our fudge. Now it boiled at a higher temperature because when you add solid that dissolves, it raises the boiling point. And if we continued to boil the water or our fudge solution, or they often call it a sugar syrup solution, we would have noticed that the boiling point kept getting higher and higher and higher. And if you looked at the thermometers when we were doing the fudge, you noticed they were marked softball stage and then firm ball stage and hardball stage and soft crack stage and hard crack stage. And I don't know if ours is also marked caramelized sugar, but that's also another stage. And the reason you can get the boiling point to keep going up and up and up is because as you boil a solution, you're losing some water. So the sugar concentration keeps getting higher and higher, and thus the boiling point keeps getting higher and higher. We noticed this in the opposite effect with salt and sugar when we were freezing it. If I added more salt, it froze at a lower temperature. The more salt you added, 1 teaspoon or 2 teaspoons, the more you added, the lower the freezing point went. Now, we didn't have to add more sugar to get the solution to go higher and higher in boiling point, because when you boil something, the water starts becoming a gas and it leaves. So as it continues to boil, it's kind of like adding more sugar because you have more sugar in the solution than you did before. And as more and more water boils away, the concentration of the sugar goes higher and higher, which means the boiling point goes higher. So when we are making candy, we are stopping at a certain temperature. Why? Because that will give us a certain concentration of sugar, and that will affect the texture of our final candy. So if we want our candy soft like fudge, we will boil it, but only to about 235, because that will have more water in it. It has some sugar, but more water than if we keep boiling it and boiling and boiling it, and we get up to the lollipop stage or the hard crack stage. And now we've gotten rid of almost all the water, and this is almost all sugar. And this is here at fudge is a combination of sugar and water. So now we can affect what candy we want by what temperature we cook it to. So now take out this handout, which you should have been given, called Candy Temperature Boiling Point Elevation. And I'm going to go through an example problem that's listed on the handout, but I'm going to talk it through with you. So we have this equation, and it's written down for you, and it's the change in temperature of the boiling point equals M. And M is not mass this time, but M is something called molality. The molality is how many moles of something you have dissolved in 1,000 grams of the solvent, which is normally water, times I. What's I? I is the ionization factor. That's talking about, does the material break up when it dissolves in water, like salt breaks up into sodium and chloride? So it breaks up into two things. So it has an ionization factor of 2. But sugar doesn't break up. It just separates from other sugar molecules. So it has an ionization factor of 1. And then this final times is Kb is a constant, and for water it's always 0.52 degrees Celsius per molality for water. And the change in Tb, I already said, was the change in temperature and boiling point. So from this important equation, we can figure out what temperature we want to raise the boiling point to get a set concentration. Or if we have a set concentration, we will know what temperature we want to raise it to make the candy that we want. So turn to the next page of the handout and let's go through an example of what we're talking about. And let's look at fudge, because that's what we've made so far. So what is the sugar concentration at the softball stage, which is the stage where we make fudge, which is 235 degrees Fahrenheit, but we're going to stay in Celsius to do this math, so it's 113 degrees Celsius. So how much sugar is that when you boil something at 113 degrees Celsius? Well, you've gotten rid of some of the water, and so what concentration of sugar is left over? You just need to plug it in this equation and follow this math, and you'll find out what the concentration of the sugar is. So let's plug in this equation. So the change in temperature of boiling is the change from the normal temperature that water boils at. So water boils normally at 100 degrees Celsius. So if we go in the softball stage, we raise the temperature of the sugar solution until it reaches 113 degrees Celsius. So it is 13 degrees higher than the normal boiling point of water. So now we plug that into our equation. So the change of temperature of boiling is 13 degrees Celsius. Equals M. M, I don't know. What is the molality? That has something to do with the concentration. I don't know what the concentration is, so that's what I'm solving for. So what is the M? Times I, and I said for sugar this is 1, so you always put 1 here, times the constant B, which is always 0.52 degrees Celsius per molality for water. So we just plug in 13 equals M times 1 times 0.52. And now I want to solve for M. To do that, I divide both sides by 0.52, and I plug it into my calculator, 13 divided by 0.52, and I get 25 molality. So molality still doesn't help me that much. I want to know what percent sugar I have. So I shouldn't say it doesn't help me too much. It's going to give me the starting point to figure out what the concentration is. So then I want to change this molality to grams of sugar so I can get percent sugar. So molality means that's how many moles. So if I have a molality of 25, that tells me there are 25 moles of sugar in 1,000 grams of water. But I want to know the grams of the sugar. So what do? Well, I would have to look this up, and we looked this up for you. Every mole of sugar, and if you remember to chemistry class, you would look up carbon on the periodic table, which is 12, multiply it by 12. Hydrogen is 1, multiply that by 22. Oxygen is about 16, multiply that up by 11, and you would get this number, 342.3 grams. So if I have 25 moles of sugar, and there are 342.3 grams of sugar per 1 mole, I get out my calculator and find out that I have 8,558 grams of sugar, right? But remember, that's in 1,000 grams of water. So if my molality is 25, that means I have 8,558 grams of sugar in every 1,000 grams of water. So I'm still not where I want to be. I want percent sugar. And percent sugar, way down here, is the mass of the sugar divided by the total mass times 100. So now I have the mass of the sugar. The next thing I need to figure out is the total mass. So the total mass equals the mass of the sugar plus the mass of the water. And we've already said the mass of the water was 1,000 grams. And we just calculated the mass of the sugar. So I have 8,558 grams of sugar plus 1,000 grams of water gives me 9,558 grams. So if I want to calculate the percent sugar, I take the mass of the sugar, 8,558, divided by the total mass, 9,558, times 100, and that gives me 90%. So when you take your fudge, and you have your sugar and you have your half and half, and you heat it and you boil it and you wait and wait until it gets up to 238 degrees Fahrenheit, about that, which is about 113 degrees Celsius. You now have a solution that contains 90% sugar. So now go to the next page, and we're going to fill this chart in what we just did. At 113 degrees, I have a molality of 25, which when multiplied by our molar mass gave me 8,558 grams of sugar. There's always 1,000 grams if I'm solving for molality. The total mass was 8,558 plus 1,000. And then when I did mass of sugar, 8,558 over 9,558 times 100, I got 90% sugar. So when you are making fudge, you are boiling it until you get to 113. Why 113? Because that will give you a consistency which is 90% sugar. And that will give you a nice fudge consistency. But if you want to make lollipops, you're going to have to heat to a higher temperature. Why? Because that will give you a higher sugar concentration, and that will give you the nice hard structure that sugar has. So now if you flip to this page, it tells you the temperatures that different things are marked on your candy thermometer. And the softball stage is marked at about this range of temperatures. The firm ball at this range, hard ball, soft crack, and hard crack. And notice it also says on this side what products we make at those temperatures. And you will notice that at the lower temperatures we have our softer candies like syrup and fondant, which is like a frosting, and fudge and pralines. And we get slightly harder with caramels and slightly more stretchy with taffy. And then you get really brittle and hard things like our Jolly Ranchers or our lollipops are cooked to a much higher temperature. Why? Because that gets rid of more water and we get a higher percent sugar, and sugar by itself is a pretty hard substance. So now what do you have to do to finish this worksheet? You're going to fill in this chart following the same steps I did. So you're going to go here, and the first thing you're going to do is calculate the molality. So you need to know the change in temperature. Well, what's the change in temperature? That's compared to 100 degrees. So for the change in temperature, if you go to 110, the change in temperature would be 10. 113, the change in temperature is 13. 119, it's 19, etc. And you're going to plug that in this equation. Oops. So if you went up to 110 degrees, the change in temperature here would be 10 degrees, equals the molality, which happens to be what you're solving for, times 1 times 0.52 degrees Celsius per molality, because that's a constant. Remember back here, our constant was 0.52 degrees Celsius molality. So you're going to plug that in and you're going to get a number, and that will be the molality of your sugar. But that we don't want to stop there, so I'm going to then multiply whatever you get for the answer to A by 342.3, and that gives you the grams of sugar. Then you want to have the total mass of the solution, which is the mass of sugar plus the mass of the water. And notice, by the definition of molality, the mass of the water is always 1,000 grams. And then finally, you're going to calculate the percent sugar, which is mass of sugar over total times 100, which will give you the percent. When you have that, you will fill in this chart with your molality, your mass of sugar, your total mass, and your percent sugar. And you will also then fill in this chart here with the percent sugars right here. This column here we'll fill in tomorrow, where we do the very fun cold water test where you actually get to feel what these feel like and look like. And most people really enjoy doing that, and I know you will too. So I will be there tomorrow, and we'll do the cold water test and see how the temperatures affect the percent sugar and how our candy's going to come out. Thanks for listening.